So let's look what happens when an object or a mass is sitting on a ramp or an inclined plane. Now, when it's sitting on an inclined plane or a ramp of any kind, there's basically one main force acting on it, and that, of course, is the force of gravity, which, of course, goes straight down. But that force of gravity actually ends up doing two things instead of one thing. Instead of just causing something to fall, like in free fall, or causing pressure on a surface, like a box sitting on a table, it actually does two things. One thing that it does is it actually causes it to go down the ramp. But of course, the other thing it also does is it creates pressure between the pumpkin and the surface. So that regular just force of gravity that typically goes down is then broken apart into two parts. One part is often called FGX, and the other part is often called FGY. Now, if I sort of take my little FGX vector that we have over here and I move it over here, I actually create a nice little triangle. Now, you might be able to tell that the angle of the ramp here and the angle of that triangle are the same. Now, because they're the same, I can use basic trigonometry to calculate how big FGX is and how big FGY would have to be. So to calculate my FGX, that would just be the force of gravity times sine theta, because the FGX is actually on the opposite side from the angle. Now to calculate my FGY, that would then just be the FG times cos theta, because of course FGY is adjacent to the angle, making it cos theta. Now if we expand this out, you'll often see FGX as FG sine theta or equal to mg sine theta, and FGY is then often written as mg cos theta. Now these two forces they do very different things. The FGX is what goes down the ramp. So this is the force that actually causes it to accelerate. So if I wanted to calculate the acceleration force, I would use mg sine theta or FGX. This force actually causes it to have pressure on the surface. So that right there actually creates the Fn. This Fn can then be used, of course, to possibly calculate some friction if there was friction in the situation. So let's suppose our pumpkin is a 6 kilogram pumpkin and I want to calculate my two forces. If I wanted to calculate my FGX, so FGX would be mg sine theta, I can put in my 6 kilograms, and if I knew my angle, maybe my angle is 35 degrees, so this would also be 35 degrees. And I do mg sine theta, and I punch it out, I will get an FGX of approximately 34 newtons. This is the force that would cause it to accelerate, so if you want to calculate the acceleration, it'd be Newton's second law, F divided by m, and that is the force that you would want to put in as the accelerating force. If I wanted to calculate FGX, or FGY, we would have mg cos theta, and we could calculate that. And if I do that, my FGY is approximately 48 newtons. And this is going to what creates my Fn. And of course, the Fn is often used to calculate the force of friction if you know the coefficient of friction. And then that friction could be subtracted from the FGX to calculate net force. So often you will see that the net force for something on an incline would be the FGX minus the force of friction, where the force of friction is mu Fn or mg cos theta.